Welcome. It's Wednesday once again, and it's time for Catalog and Cocktails. It's your honest, no BS, non salesy conversation about enterprise data. And you've got Tim Gasper over here. I am a data nerd and product guy, and joined by co host Juan. Hey, Juan.
Hey, Tim. I'm Juan Cicada. I'm the principal scientist here at Data.World, and it's Wednesday, middle of the week, end of the day, and it's time to take a break and chat about data and all that stuff that we do here at Catalog and Cocktails. And today we have very special guests because all our guests are awesome. They're so cool and very special. But today we have Kirk Borne. And Kirk is, who doesn't know who Kirk Borne is, right? He's like one of the top influencers in the world on data science. And he's also the chief science officer at Dataprime. Kirk, how are you doing?
Good. Thank you. Glad to be here. This is great.
Awesome. Yeah. So we always like to kind of kick it off, with our tell and toast. So what are you drinking and what are you toasting for? So,
well, I'm drinking water. my wife said, avoid anything else. I'm drinking water. And I guess I'm toasting the start of the school year because it's all about learning. For me, my lifelong learning is a passion of mine. And I have grandkids now. And when I see them getting excited about going to school, I said, this is wonderful. So toasting all the teachers, educators, administrators, students, and all the parents. Wait a minute, we haven't covered everybody in the world yet.
How about you, Tim?
No, that's awesome. I'm going to end up toasting to the same thing because we're actually getting our kids going in school now. I got one kid in in-person school, and I got one in virtual school, and I got one who isn't in school yet. So, oh my goodness, things are just still crazy. But the drink that I've created today, it's actually based on a shrub cocktail called La Jolla, but instead of tequila, I made it with pisco, and I actually added a little bit of blue curacao in here to make it look like a turquoise color. So I call it a Trisacola, which is a Peruvian gemstone. This is a Tim special. I don't think this exists, so hopefully this tastes good.
Awesome. I haven't had pisco since my trip to Chile.
Well, always a good discussion is where does pisco come from? Either from Chile or Peru. That's another.
I don't know, but I had some in Chile.
Well, I only have two things right now where I am. I have beer and vodka. So I looked up what can I do with beer and vodka, and here you go. It's a twist on the Shandy beer. So I have a Stella. I added some of this tamarind Smirnoff vodka. I had some honey and lemon, and it actually is really, really good. I'm surprised. Like, you would not think vodka and beer would go together. At least this vodka that I have.
It kind of does sound disgusting, I'll say.
I would. Yes. And I'm actually toasting for today is my wife's birthday. So
hey, happy birthday.
Happy birthday to my wife, Fabiola. Cheers.
Happy birthday. And cheers, Kirk. Welcome. Glad to have you here.
Awesome.
So our warm-up question today is, what is the buzzword that makes you want to pull your hair out?
Well, I don't have much left, but
you've gone through a lot of buzzwords, right?
I've thought about it, and I guess one of the words that really gets me going is maybe two words together: exponential growth, because people use that phrase and they have no clue really what they're talking about. Because exponential growth doesn't mean that it's going up; it means it's going up at a certain rate. So anyway, so to tie that back to a data comment, I would often tell people the difference between linear growth, exponential growth, and combinatorial growth. All right, so linear growth is like 2 times x. Exponential is like 2 to the x power, and combinatorial is like x factorial, which is like x to the x power. So that's way faster than 2 to the x to the x. And so when people say to me they have exponential growth of data, I would say, really? So little?
And then they're like, why are you making me be literal here? Like, I'm trying to evoke a feeling.
That's the honest, no BS right there. Tim, how about you?
One of the buzz phrases that I've been very annoyed with lately, makes me want to pull some of my hairs out, is the phrase data intelligence. Which to me, like, I know people are trying to apply it to represent certain areas of, like, doing more with your data and being smarter with it and driving action back. But like, I feel like it's such a generic phrase. And when folks are saying like, we're trying to achieve data intelligence, I'm like, well, And anything you do with data is hypothetically, hopefully, an intelligent use of that data.
Well, I mean, I forget the phrase. I'll look it up again, but it's like the opposite. Wait, so you would do something unintelligent with data? No, it's obvious that whatever you want to go do with data is intelligent. So you're telling me the obvious. Thank you.
Yeah.
I guess.
Yesterday I was doing data stupidity, but then I had a euphoric moment where I was like, oh, I gotta do data intelligence. So that's
well, maybe that's what they're saying.
maybe.
Well, mine is there's a combination. One is the old one that we've been now old, but big data. I mean, the whole we're doing big data. We're doing big data. I'm like, wait a minute. The amount of data you're dealing with fits in my pocket. Literally, it fits on my phone. Heck no, it's not big data, right? And then when we start talking about efficiency and scalability, it's like, wait, what does efficiency actually mean? Your context and stuff. So, yeah, people like to throw those words around, and what does this actually mean? So, hey, I always say words matter. So, talking about words matter, let's jump into this discussion. So, Kurt, honest, no BS. We're going to start demystifying some buzzwords here. What the heck is Industry 4.0 or Industrial Revolution 4.0? I know I've heard and seen this more from the Europeans, right? Especially the Germans use a lot Industry 4.0. This is something I don't see a lot in the US, but we're kind of starting to see it more. And what the heck is Industry 4.0?
Well, I think the Germans are onto something there. So I like to talk about it in the context of the first three industrial revolutions. So Industry 4.0 represents the fourth, and the first came about with the steam engine over 200 years ago. And I specifically make reference to how the industrial revolutions changed the way work is done. So at the dawn of the first industrial revolution, 90% of the U.S. workforce was doing farming. And then 100 years later, the electricity revolution started, and electricity became the main source of power in industry. And by the time this was underway, as a result of the preceding industrial revolution, in that 100 years, the percentage of the U.S. workforce that was farming dropped from 90% to 50%. Well, in the next 100 years or 80 years or so, probably about 80 years or so, we got to the computer revolution, which was the third industrial revolution, which really started about 50 years ago. And so the computer revolution, by the time that started, the number of people who workforce percentage doing farming dropped from the previous revolution from 50 now down to 5%. So the key thing during all these revolutions is not just sort of the power source, if you will, but also the way we do work. Okay, so starting with almost everyone doing farming to half the population doing farming to just a tiny percentage of the population workforce doing farming to the current age. We're literally 0.5%, like 0.5% of the workforce in this country are farmers, and yet we're feeding 10 times as many people as we were 200 years ago, at least these people. And so what is it that's really different? We're still in the computer age, right? That hasn't changed in 50 years. So what's really changed is this era of hyperconnectivity. Everything is connected, right? And so through our smartphones, through our devices, even our cars are connected, our homes are connected, the roads are connected, everything is. So it's really an era of hyperconnectivity. So what powers thing is the knowledge that is transported across the computer networks. So it's not just using computer networks to connect to a computer, which is sort of how the computer revolution began. It's now knowledge itself is being transmitted across the networks, and it's powering work, it's powering homes, it's powering life. Think about work from home in the last year. I mean, all this hyperconnectivity. I don't think we could have worked from home 50 years ago, even let's say 35, 40 years ago when the PC revolution started. If we just gave everyone a PC and said, go work from home, it just never would have worked out. But I think because we have this hyperconnectivity across everything, our platforms, our banks, our homes, our cars, our smartphones, our apps, Zoom calls, platforms like this. I mean, we're just all connected. And so the way work goes now is completely different than it ever used to. So that's how I see Industrial Revolution. It's sensors and data everywhere, powering and informing and changing the way we do things.
So to kind of be a little pedantic on here, wouldn't this just be like 3.2 or 3.3? I mean, because the things that you mentioned before, like steam, electricity, computer, like these things fundamentally changed society, right? From going from steam to electricity and then going to computers. But what you're talking about are more kind of specific type of computers, right? What do
well, not well. I would say like AI, for example, is probably the thing that's fundamentally different than just having the computers we had 50 years ago. And it's sort of like a parallel to farming because people didn't stop doing farming when the steam engine came along. They just did their farming with steam powered plows and steam powered combines and things like that, right? So they were still doing things similar. It's just that the way they did it was so much more effective. It freed up people to do other things, and that's what I think AI is doing. I mean, I've been looking a lot into sort of voice assistants and how voice assistants, and customer call centers and a lot of different ways, how it's really changing the way that customers interact with businesses, and how clients and business providers interact with one another. So it's not really like necessarily changing that how we're doing business. It's just the whole transformative way of efficiencies and effectiveness of different things are made so much better that we can now start trying many new different kinds of things. And so that's really the revolution. It's really this transformation and disruption of the old ways and introducing all kinds of new ways. And I think the AI part of that story, because AI is actually, to be really an intelligence, and maybe this is my sort of closing comment on this, is that intelligence, to me, is really about not just having, finding one pattern in one stream of data, right? So let's say you have a time series, and then you see a sudden rise or decline or a glitch or something in the time series. That's not really intelligence. Intelligence is the full cognitive awareness of why did that happen? What's going on around that? And so we talk about, in psychology, you talk about cognitively impaired people, right? So a cognitively impaired person could walk into a room and make some really off-the-cuff comment that doesn't work in that room, right? They can't read the room. Like I walk into a board meeting and I make some silly comical comment during a very serious time in my business. That's really not being very cognitively aware of what's going on. So cognitive intelligence is about seeing and getting data and information from everything else in the environment, so you make the best decision and take the best action. And so I think what AI does for us is, if it's really going to be an AGI, a general intelligence, it has to have this sort of cognitive ability of getting context. And this is where the hyperconnectivity of Industrial Revolution 4.0 gives us that connectivity to the context in which things are happening in our world, in our work, in our lives, in our homes, even in our cars.
That's interesting. You when you talk about hyperconnectivity, obviously there's a connectedness and networking aspect to what you're talking about here. But then when you talk about AI, there's more of a sort of the way we're applying the models, the fact that we're able to leverage the data in a smarter way. When I mentioned about like my buzz phrase, right, data intelligence, it sounds like you're also kind of connecting it to how that phrase can actually be a useful phrase, which is to think of that as a goal, as a higher sort of plane of what we're doing with our data, with our computers, that actually is novel, is a step up. Is that the right way to think about it? And then secondly, like, so why are people getting so excited? Like, what is actionable about this that's different than, maybe the computer revolution and what that enabled?
Well, I think you hit the nail on the head there with connected intelligence, right? So for one thing, for sure, you just think about breaking down the silos in business. I mean, businesses always have been, well, not always, but for many years, decades, have been doing business intelligence. But that business intelligence usually lived in silos. So the marketing department, the product department, the sales department, the customer care department, those people didn't share data with one another. So maybe people are calling up about some defect in the product and no one's getting the message in some other part of the business. So the connected intelligence is what's really making this difference. And of course, there's so much data, it's hard to do that without something to orchestrate the flow of that information and knowledge. And that's where the hyperconnectivity and AI come together. So let me give you an example of how something can be really different from what historically is, and that's the digital twin. So digital twins are really big in Germany. So you talk about Germany being pushing Industrial 4.0.
I'm glad we bring in digital twin, because that's like another buzzword that comes in here. So what is a digital twin?
So a digital twin is a computer model of a real physical thing. So NASA was one of the first agencies or groups in the world to actually introduce digital twins, where they made a computer model of the thing which they deployed in deep space. Okay, so they could run it through the paces of the thing going on in deep space. So whenever there was a problem, they could sort of replay it. They have the data. They've collected the data from the real physical system, and they can just basically re-record it, or not re-record it, but replay the recording, so to speak, and figure out sort of what was going on when it glitched. Okay, what kind of things are happening, and find a solution. So industries are doing this now, in manufacturing plants, on engines of all sorts, jet engines, all kinds of engines. I've seen that. I actually walked through a virtual reality demo of a windmill, a solar, wind powered, not wind powered, wind energy generated windmill, where they actually had the ability in this VR environment to actually go to climb into the gearbox of this 200-foot tall tower and poke around in the electronics to see what was the problem. But you're not really in the gearbox. You're actually in a simulated environment, a virtual reality world, playing with the simulation of that windmill. So if I tweak this, tweak that, how does it behave? And so you can actually, excuse me, fix problems, identify precursor problems like preventive and predictive maintenance and that kind of thing in the computer before something really bad happens. And so building these sort of connections between real world and simulated world is really one of the real amazing differences now in this hyperconnectivity we're now talking about. And in the past, you could probably build that simulated instance of the physical thing, but you never could really connect the two data sources.
So okay, so a couple of things I want to dive in here. One is, we as I mentioned, Industry 4.0 is something that we've hear more coming from Europe, especially from Germany in particular. I postulate then that the reason why this happens is because you have the Germans are great on manufacturing, right? On cars and stuff. I mean, talking about the digital twin, right? It's about manufacturing, about engines and stuff like that. So is that kind of the connection right there? That's one. Second, here in the US, I'm starting to go hear this more. And actually, I think many years ago, it started like with GE, right? GE was like one of the first companies I started hearing more. They talk about digital twins again for manufacturing. Now, I get the definition of digital twin. It comes from like the actual engine or stuff, right? I like how you just said it's a computer model of the real thing that you want to go simulate it. Basically, you want to go replay what happened before. The thing that really I call BS at this moment, because it's still not clear to me, and people are just throwing this word, is when they say digital twin for any other non-manufacturing enterprise, right? And it's like, well, here's my, I don't know, I'm an e-commerce company and whatever, like, and we have a digital twin ourselves. It's like, digital twin of what? Of your entire company?
Yeah,
Or
is it fair to apply it that broadly? Like, for example, I've heard people talk about digital twins in the context of like marketing and like trying to do something around a person doing things, and this is their digital twin. Like, can we use it in that way, or is it really more of a sensors and more of a manufacturing type of situation that it's more appropriate for?
Well, I think you could get to these extremes where people will use that word again as a buzzword. Okay, let's say it that way, versus a more real practical thing. And I've seen digital twins of entire manufacturing plants. I mean, articles that talk about the digital twin of an entire manufacturing plant. But what I think sort of what softens the blow in that conversation is it's all about the sensors and the data we collect from sensors that lead to predictive models that is predicting if something will happen given the stream of data. It's also about prescriptive models saying, well, if we tweak this, what will the outcome be? If we tweak that, what will the outcome be? And so I can see that being a very reasonable thing in marketing, for example, or a very reasonable thing in a manufacturing assembly line, for example. If we change this or change that, what would the outcome look like? And so you have to have a pretty high fidelity model of the thing you're simulating, right? You don't have some simple model. You need to have a model that really captures all the moving parts, so to speak, whether it's a customer or an e-commerce store or a windmill or a jet engine.
You need a lot of data, right?
Or
good signal.
Exactly. So now you need a lot of data. You need the predictive models, okay, the causal models, which I call the prescriptive models, like what will cause what to happen if we tweak something, but also root cause analysis models, where you can replay the data when the thing did fail to say, well, what was it in the history of this that caused the failure? So we don't allow that to happen again. And so you got to have high fidelity, you got to have data. And again, there's got to be this connectivity, because it's not just simulation of data. It's taking the real data from the real system and what's called assimilating it into the model, into the simulation. So data assimilation, I learned from NASA days, and that's a really powerful tool where you bring in the real live data into the simulation to update it.
So I think a big thread here is about connectivity, and we're talking about when it comes to connectivity of data, it seems that we have a lot in the manufacturing space. At least there's a lot of sensors, and I think that's one of the stuff that we get a lot of data, and that data needs to be connected and stuff. But then there's also this connectivity of knowledge, which in reality is going to give us that extra context, give us of all that data that we're producing to understand what it means, such that we can go do more fancy AI stuff. Because if we're just focused on the data itself, I mean, without that context, without that knowledge, it's almost kind of still garbage in, garbage out in a way. Or we get enough, but we're getting the obvious in a way. That's kind of the takeaways I'm getting right now is data, connectivity of data with sensors and connectivity of knowledge is what we really need for AI.
Yeah, and I think I'm going to get a little philosophical here. I mean, there's been this diagram that people have used for years, talking about going from data to information to knowledge to wisdom. We've all seen that pyramid, right? And so I actually use that a lot in my talks. I say, well, what is data? Well, data are the ones and the zeros. Those are the bytes you collect from your sensors. So by themselves, they're just ones and zeros. Information is something you extract from the ones and zeros. So let's say I have a satellite image. This is my example from NASA. People look at a satellite image and say, oh, that's a cool picture of a volcano or a flood or an iceberg or something. But if you just gave someone this file and you didn't tell them what it was, and they tried to break it apart, they would just see ones and zeros. That's all you'd see. All right. So we know it's an image, so we actually display it as an image. But what you extract from that image is, for example, the location of the event, the type of event, how big it is, time of day. You extract information from the ones and zeros. Now you connect that to something else. So here's a flood. There was this wildfire in that part of the country last year, burned all the brush, which made all the topsoil run off, and therefore you end up with this floodplain because all the fires basically burned out the brush that would have withstood the heavy rain. So now you got this runoff and you got this flood. And so NASA's analyzing floods across the world in the context of climate change, when you look at increased number of wildfires and increased drought conditions and all kinds of stuff. And so now you're connecting all these pieces of information from the data bits to great knowledge. And from that knowledge, I say, when this happens, this will happen. And so that connectivity now gives you the wisdom and know how to act, know what to do next, because you see the sort of the causal connection between things. Instead of, like I said before, I take an image of this location on Earth, I take an image a year later, and I see something's different. Oh, okay, so there's something different. Okay, I saw something different. Someone wants to know, well, why, how, what? I mean, that's how you become a cognitively intelligent person. And that's how our intelligence, our data, our AI becomes cognitive, and our real AI becomes intelligent about seeing those factors, those causal connections, again, but also able to build predictions from it, predictive models, and then again, prescriptive models. That is, well, how can we do something so it doesn't happen this way again?
Yeah, I love how you're saying the notion of being cognitive is ask the why. I think that's something really important that we as humans ask the why, right? And if we're expecting machines, AI to go do that, like that's the true kind of measure right there, is not the intelligence of how cognitive things are, because we ask why is this happening? And I love that same example that you're doing about the data, information, knowledge. My example is, if I see a number, right? Okay, here's a number. 42. What does that mean? I don't know. Well, then
that's a good choice, by the way.
Yeah, purpose. I do that, right? Okay. Well, then next to 42, I have this thing called USD. Oh, that's a currency. So now 42 USD can mean something about a price or whatever, right? But then you want to go get more context around it. It's like, well, I have this thing, an attribute called the net sales. Oh, something was sold and this, and then you get more context about it. Oh, there's an order and there's a customer and so forth, right? And then you start asking these questions. It's like, wait, who's buying this and why are they buying it? How come they're not buying more, right? Or how come they're buying or less, and so forth, right? So this is a great way of thinking about it, having these examples of all the way from data all the way to wisdom. I love this.
And you just described the whole connectivity thing. You're connecting all these different dots, if you will, all the data points to get the understanding of that number, that 42.
Yeah. Tim, as we always say, it's knowledge first, right? This is the stuff that we're realizing right now, that we've always been in this data first world, that we just need to start thinking about. It's not just data first; it's knowledge first. It's connectivities.
Mm-hmm. people and
Yeah.
connections and context. Yeah, I love where this conversation's going here. And, as we talked about, um, sensors and around Industrial Revolution 4.0, this idea of sensors and getting all this information, it kind of leads to our second buzz phrase here, which is intelligent edge. And one of the things that I'm very curious, Kirk, is how do you think about what is the intelligent edge? And, what are the implications of that? Does that just mean like, right now we're gathering lots of data and it's going in our data warehouse and we're running our big models on it and that kind of thing. And just, we're going to push more of that to the edge. We're going to process more of the edge. I guess, what do you think? What is intelligent edge?
Well, it has a lot to do with autonomous systems, first of all. All right. So clearly you can collect data, store it in a data warehouse, and spend the next 6 months analyzing it. And so you don't want to do that in a self-driving car, right? So a child walks in front of the car while you're driving, and a camera is watching the front of your car, and it sends the data back to the cloud, and you analyze that data, and 15 minutes later, you say to the car, oh, you need to apply your brakes. Well, it's kind of late 15 minutes later, right? Because the kid is in front of your car 15 minutes ago. Okay, so the intelligent edge is the ability for a system to respond and take an action, take a decision or whatever at the point of data collection. Now that requires something called edge computing, that is putting the smarts as close to the point of data collection. And so we now have sensors that have ML built in. So you may have heard of tiny ML. So tiny ML is an example, and there's other things like this. There's sort of neural chips, sort of neural processing chips, NIPs, that will actually do process and neural networks even on the chip as you collect the data. So it basically, so computer vision is a straightforward example, right? Your car needs to interpret what's in that image, so the car can take the right action in that moment. But there's also intelligent edge of things which are sort of less critical or less intense as that. It's, for example, just postal code scanners, right? So a package runs through your mail and it scans like zillions of packages per minute, and it reads those postal codes, which are written by human hands. So people write numbers in all kinds of different ways. Okay, so there's examples. There's intelligent as even in an e-commerce store, that the moment a person is clicking on something, maybe there's an action that can be taken autonomously by the driven by the web analytics of that particular customer interaction. Even in Fitbits, or wearable health devices, you want to get some kind of feedback. For example, if you're getting some kind of alarm that your heart rate is out of balance when you're exercising, you want to get that alarm now, not after you've passed out on the street. Okay, so intelligent edge is really about getting that intelligence, and it includes the cognitive thing we were just talking about, the contextual information around that at the point of data collection. So the edge can be anything. It can be that at the point self-driving car, it can be in a health environment, it can be in a manufacturing environment, anywhere where you sort of like you need information, knowledge, and understanding at the point of data collection.
So this is reality today. Everything, all those examples that you're stating right now, those are happening right now. So this intelligent edge it's not a buzzword anymore. Then it's a reality.
Well, what makes it different now is the Internet of Things, because the Internet of Things is predicted to be, 25 trillion sensors on the world. So we're really creating an intelligent edged world, right? And I've seen the numbers. Different groups have sort of projected the market value of the intelligent of things market is anywhere from 1 trillion to several trillions of dollars in the next 10 years. And so businesses are realizing that they just can't bring all that data back to a warehouse and try to extract the knowledge and intelligence out of it over a period of weeks or months. They need it now, action now. Excuse me. So so I like to talk about Internet of Things a lot about this, and I like to use a phrase for the Internet of Things. I call it the Internet of Context. Okay, so all these sensors in your manufacturing plant, in your car, in your smart home, in your smart city are giving you contextual information about that environment. Okay, what's going on in that space that help you. So when you see something unusual in a particular sensor, you now have the context of what's going on at that same time in that same area. So all these sensors by themselves give you information about whatever it's sensing, but also gives you contextual information about the environment it's situated in, whether it's in a manufacturing plant, your home, your car, your city, whatever. So Internet of Context to me is powering the intelligent edge, because it's not just the one, again, like you said before, it's not just the ones and zeros, the 42. It's what else does that 42 correspond to, or what is it related to? What is it connected to? What is it associated with?
Being able to embed more meaning in all of this. We've got a lot of folks on this podcast that are data people, right? Whether that's, analysts or architects or, folks that are organizing governance initiatives and things like that. And as they think about the intelligent edge, there's obviously an aspect of this that is more, how this is, the sensors and the intelligence are being implemented in the products themselves, into the assembly line. How does this impact data professionals, right? Does the stack change? Does the skill set change? What's the impact and relevance there?
I'm sure it does. I mean, so I'm not a data. I'm not
we'll
a data.
Find out together.
I'm not a data engineer. I've worked with a lot of data engineers, but I never pretend to be one. So I'm sure the stack's going to change. For one thing, like I said before, a lot of the smarts it's now in sort of the microcode in these newer chips, right? And so at some level, you're not even needing. You can imagine almost not even needing to know machine learning, because it's already in the chip. So you need to buy the right chip. Something. So for example, there's particular chips that actually have cameras in the chip, right? So it actually collects the data, the image, and does object detection in real time. And I heard someone talk once at a conference. I still don't understand exactly what they meant, but they basically did it was a behavioral chip. All right, they detected behavioral patterns in real time. And I don't know what that meant. It meant, maybe it meant trend lines, maybe it meant anomaly detection. I don't know what they meant, but behavior.
The word behavioral is another tricky one.
Behavior on a chip. I don't know. That sounded kind of interesting to me. So, but I can imagine that, for example, in a like a stock market high frequency trading instance, where you want to see what the behavior is instantaneously as best you can when there's a very high volume of stuff going across the wire. Okay, so what is the behavior at this moment of this ensemble of traders or something like that? And so I don't know if that's what they meant, but it's an interesting concept to me of how you can whether behavior means like ensembles or segmentation or outlier detection or trends or correlations. I'm not sure, but it sounded really interesting.
Yeah. Well, and the idea of more of the, even just that comment that you made about like the chips and, more of the machine learning being executed on the chips or behavioral analysis or whatever things they have deployed there, that's different, because obviously the state of data science today is much more focused on the idea that like, well, I'm going to collect all the data. And then I'm going to run a bunch of stuff on it, and maybe I'll build my knowledge graph and stuff on it. But it's much more of like a collect and then build. Whereas there's this whole aspect of the edge, which is like, no, there's things that are like forward deployed, some of which is like hard coded that like, well, how does that interplay? And how do you iterate on that? I don't know. It's interesting.
So there's a cycle here. Right. So at the end, if you're pushing something back onto the edge, right, that's going to do the machine learning, the AI, right, that has to come, like that model has to come from somewhere. And that's going to come from, there's an initial model that was created. So you're going to still do your traditional, our traditional data, gathering data, bring it all integrated and bring it all together, doing some machine learning stuff. Then you have to go figure out that I need to take that, put it back into the edge, onto the sensor, whatever, because it's going to feed that. And then there's new stuff that's going to come out, right? I'm going to be making some decisions at that moment. I'm going to learn new things. I need to then send that data back to the central place and keep updating the model, then send the model over there. Like there's this whole cycle that needs to occur over here. And are we actually prepared for like people we talk to? Like, I don't even think, do you know how to go take your model and update it and go send it to all the different millions or billions of sensors that are out there and making sure that because just doing an update, right? I got to go update my sensors for the new model that we have, because we realized that the previous one was screwed up. It had an error, there's bias and stuff. Like there's going to be so much governance and things we need to go track about this. Like this is I'm now realizing this next frontier is going to be so much more things to go keep track of.
Oh, you're such a doomsayer.
Hey, it's more problems, more things to go work on.
Opportunity.
Opportunities here.
right?
Well,
I mean,
let me tell you a story. I mean, I worked at NASA for 20 years, or in some capacity. I was never a NASA civil servant employee, but I worked on projects with NASA, Hubble Space Telescope for one. And I left that role 18 years ago. But even then, 18 plus years ago, we were talking about this very topic. And so we didn't have too many GPUs in those days, but they had these FPGAs, floating point graphic accelerators. And the FPGA was essentially what you were just describing. It's a programmable chip. Okay, so NASA's idea was we were going to deploy these chips on our deep space probes, and these probes would be programmed to do certain things, like collect soil samples on Mars, take images of the moons of Saturn, measure electron density in the interplanetary medium, things like this, right? So, but you want to be able to recode that if you discover something and you say, well, we were sampling this every 30 seconds, but we better start sampling this every 5 seconds because there's something going on here. Or conversely, gee, we don't need to sample every 30 seconds, maybe every 30 days because it never changes. All right. So we were having this conversation about how do you update the microcode on the chip, in a remote sensor based upon data you've collected, and then you upload new code back to the sensor so that as it's collecting data, it's doing the right thing. And so it's not quite as much detail as Juan you were just describing, but it was the same general idea, is that you need to update the computing that's happening in the remote environment. So NASA never called it edge computing, but that's basically what they were doing, right? They'd send these probes in deep space, and you couldn't wait for a command from Earth because the light travel time for the probe to report back to Earth, hey, I got a problem, and then Houston to send back a reply would be hours, right? It needs to decide in real time. And so a lot of the programs that NASA sent up their probes, they have what they call safe mode. If something just goes bonkers, okay, it turns off all the sensors and puts everything in a safe operating condition. So it stops doing all things that might be upsetting to the machine, and just say, okay, let's turn everything down, put it in low power mode, wait for a command from Houston to tell us what to do next. Okay,
it's like a timeout, right?
A timeout, exactly. And so that's how they dealt with it, because so we can't put, these are small. The things that are shipped up there in space are small, right? I mean, we're only getting to the age now where we're talking about sending really huge things up in space, right? But those initial probes, they were the size of a water bottle. Okay, so weren't very okay, a little bit bigger than that, but not much. So they had to have sort of limited resources on the ship, and then they had these ways of dealing with issues like that. So then they started talking about what can we do about sending reconfigurable chips up there, things that we can reprogram in that remote environment. So anyway, I'm just saying this because it's not a new conversation. It's just now we have capabilities we never had before to do a lot of cool things. We never talked about putting machine learning on chips like that. We weren't talking about AI on the chip. We were just talking about, instead of sampling every 30 seconds, sample the data every 5 seconds of this particular data. So we weren't doing any rocket science. Well, I guess we were, but anyway.
We weren't doing data science. It was only rocket science, right?
Yeah. Oh, it was only rocket science. That's right.
But a lot of the conversation we're having now, it seems to me that it's more about the sensors, right? The actual things the Internet of Things. But not all companies are dealing with sensors, right? I just got a bunch of data. I mean, you were mentioning before, Kirk, like, I have my e-commerce, and we have a e-commerce company, and they want to go do something real time very quickly. And you said something like, let the web analytics. That's the edge right there. How does this whole notion of edge, intelligent edge and stuff works with companies who are not dealing with sensors? Or is this more around sensors and that type of hardware?
Well, you're right. I mean, if they're not dealing with sensors, it makes less sense. But we're more of us are dealing with more sensors than we care to admit, right? Because there's this thing called a smartphone, all right, and every employee has a smartphone, and they tell you where people are, where they're moving, what they're doing. I mean, there's all kinds of information being collected there, right? And okay, some of that might be surveillance, and we got some legal issues here, but not all of it. So when people are shopping online, where are they shopping? Hey, if you're shopping in this mall, and I know that you're shopping at that mall, and my store has a sale, maybe I can just sort of drop an ad in one of those apps you're using, right? So that location intelligence can be very powerful for even small stores, right? They don't, and then again, it's edge intelligence, because you got to know that the person is doing this thing at this place at this time, or shopping for this particular product. So you need to have that extra contextual information besides, oh, maybe this person would like to buy, a book on tiny ML today. Well, no. Well, maybe they're actually at a restaurant. Maybe they would like to know what are the sales on these types of foods today instead of tiny ML books.
So this is a good point, because technically everybody is connected somehow to sensors because of at least their phone, right? So so we always have this notion, like you're going to be related to this intelligent edge somehow, because if you're dealing with phones. Now, one of the things that worries me now is that you look at all the apps I have on my phone, and I'm like, wait, this is an app that deals with pictures, and I have to go download this 300 megabyte app to go do some stuff. Is like, really, are people not even being trained then to go deal with, think about being cognizant with the amount of space and time that they have on a phone?
Well, I think we are in the era of small data, right? So this is one of the emerging trends in the Gartner hype cycle this year, small data, because we're realizing that we need laser focused, targeted, personalized, hyper-personalized data. So hyper-personalization is one of the consequences of this industry 4.0 we were talking about, this hyperconnectivity. Once we see all these connections, we it's like a big knowledge graph, right? We focus down on the very edge and nodes in that knowledge graph that matter in this moment, in this time, in this context. And so what you really brought up to me is what I call the space-time continuum of data. All right, because no matter what your business is, something is happening at a place, at a time, but it's not just those coordinates, right? So I'm a physicist, so I learned about hyperdimensional coordinate systems. We got time axis and the space axis. So Albert Einstein correctly pointed out that this is a space-time continuum. Those axes, space and time, are interchangeable in the right way. Well, we also have another kind of continuum of data, the characteristics, the dimensions that describe a customer, or the dimensions that describe a product, or the dimensions that describe the market or describe your company. Okay, columns, think of them just columns in a database. You got XYZ coordinates of something or a thing or a product. We got the time, the day, whatever. And we got these other dimensions. What's the product? What's the customer? What are they buying? Where are they? I mean, anyway, so it's a hyperdimensional space. It's a space-time continuum that every business, every company lives in. Now, whether they want to explore it that way is up to them, obviously, and whether it makes sense for them to explore it that way, again, is up to them. I'm not saying that it makes sense for every company to do this. Okay, but look at that hyperdimensional space and saying, when this thing happened, what else was happening in that space? So I talk to people about what I call the stellar analytics scorecard. And three of those dimensions, STELLAR, is edge, location, and related entity. ELR, but I won't get bored you with all the other ones. Team analytics, agile analytics, they got some of those letters in there. But time, okay. So edge computing is basically the edge at the moment of time. What's happening at this moment in time. Location analytics is what's happening at this location. For example, you might be at a sporting event, and it's important to know you're at a sporting event before you get recommended a certain thing. All right. And there's also R, the related entity analytics, which is those other dimensions in the space-time continuum. What other things are like this and this in my data space? Products, services, other customers, other behaviors, other preferences. Okay, so look at that hyperdimensional space, do the segmentations and the clustering analysis in those hyperdimensions in space, time, and related entity. Just your features in your feature engineering. So you still need the data scientist to figure out what are the important features. And in that space, now you're not doing just edge computing, you're doing intelligent edge, because it's all about the where in time, where in space, and where in that related entity space is something happening, and what do I need to do, and what action do I need to take next because of this.
And, this idea of small data and this idea of the space-time continuum of data both feel like not only are they very interesting in terms of spelling out where the intelligent edge is trying to drive us towards, but also they feel intimately connected with this idea of the knowledge graph and the fact that knowledge and wisdom, if we go back to that analogy we talked about earlier, right? That if it's a pyramid, ideally the wisdom and the knowledge is actually smaller data. It's the moments of intent. It's the critical pieces of information that are the conclusions, that are the things that you were trying to boil down to, as opposed to the big ocean of everything. It seems like we're trying to do a better job of getting to that top of the pyramid there.
Yeah. So the knowledge graph itself can be large, right? But the part that you need, the key edges and nodes in that graph that say this causes that to happen, and therefore when I see this happening, I need to do this to cause the better outcome. Okay, so you need to so knowledge is knowing how to navigate through that knowledge graph, just like through your data graph, to say what are the things that I need right now in this moment to do the right thing. Now,
yeah, there can be a lot in the knowledge graph.
Can I just say something about e-commerce stores? Back in the day when I was working on these really big data astronomy projects, and we invited this guy from eBay. I won't name him because he's pretty active in the world, but anyway, one of probably the smartest people in analytics I think I've ever met in my life. I mean, he just told the most amazing stories. This was like 15 plus years ago. So he was the director of analytics at eBay. And he said, we do A/B testing on eBay. And of course, at that point, as an astronomer 15, 20 years ago, I wasn't thinking about what A/B testing was. So he explained how, they changed the font sizes and the colors. They changed the size of the image of the product that's being sold, the location on the page. Where do they put the price? Where do they put the bids and the latest bid? I mean, so they move things around all over the place to see what really works. And he said, okay, so we do A/B testing. We try the change. So that's the A group, and then we have the control group, the B group, where we don't make the change and see what the responses are to the changes. Okay, so I'm thinking now. Okay, I get it now. So what are you telling me here? He said, well, guess how many A/B tests we do every day on the eBay e-commerce site? I said, I have no idea. 100,000. I was just being really extreme gross. Like it's not going to be 100,000, right? So I just said that number. He said 30 million. I said, wait a minute, 30 million per day? He said, yes, 30 million tests per day. We're talking about edge intelligence here. They're finding out in real time, 30 million times a day, what works and what doesn't work on their e-commerce site. Now, granted, they're eBay and they have an enormous e-commerce site, but nevertheless, it just completely startled me. And this was very highly irrelevant because I was working on this astronomy project, which is just going to start. It's actually going to start next year, the survey. It's been taking 20 years to build the telescope in Chile, by the way. Sarah Pinchon. It's going to collect images of the sky, the whole southern sky, every 20 seconds for 10 years. During the night, of course, not daytime. Every 20, and it's going to image 100 million objects every 20 seconds. And because the night sky is variable, stars vary, black holes vary, galaxies vary, all kinds of things vary. They move, they change brightness. There's going to be like 20 million events a night. That's nothing compared to the 30 million things this guy was testing. We had at 20 million times a night. The astronomers, I no longer work on the project, but I did for many years. 20 million times a night, you got to make a decision. Do I take an action or not take an action when I see this unusual thing happening in the night sky? An action might be to notify someone or do whatever. But anyway, the idea is that's edge intelligence, because you can't send it back. What they're going to do is they're going to ship all the data back up by fiber optic cable under the Atlantic Ocean back to the United States to process it. But it's going to take a year to process a lot of data like that.
This is
so the National Science Foundation, which funded this project along with the Department of Energy for different reasons, $1 billion of your tax dollars at work. One of the requirements on the project is within 60 seconds of that image, you have to alert the world what's going on in the sky. 10 million times a night, you have to publish an alert for every single one of those events. And so you have to define, what do I mean by an event? What do I mean by something changing? What do I mean by something being interesting? I mean, okay, now we're talking like domain expertise to the max here. But it all starts with the data bits. The data bit that there's an outlier, there's a trend change, there's a color change, there's a movement change. Oh my gosh. So we can define in words that any human can understand. It got brighter, it moved. But then say, well, okay, why is that important to an astronomer? Now you have the domain expertise that defines sort of the knowledge that's in that particular piece of information.
Right. You've got
to the world.
You've got domain knowledge here. You've got big data here. Right?
Yeah, so
you've got a lot of moving pieces that are part of this.
Yeah. So what you can do is you can subscribe to their email stream and get 10 million emails a night for 10 years. Okay. No, I'm kidding. I'm kidding. You don't do that. So what they're creating is basically a data catalog, and I think you love that phrase. Since we're on the catalogs and cocktails, they're creating a data catalog where you can subscribe. I want specific types of events to be alerted to. I'm a supernova person, let's say. So a supernova, an exploded star has a very specific characteristic. So when you see this characteristic, I want to be notified. And that'll happen maybe 10 or 100 times a night. So I don't mind getting a 10 or 100 emails a night. If you see this kind of fast-moving object of this brightness, it might be the killer asteroid that's going to wipe out civilization. I want to know about that one. Fast, please. I want to check my 401k, make sure my children are safe. Oh, wait a minute, all civilization is going to be wiped out, so what difference does it make? I want to go get that. I want to go get that steak dinner I've been denying myself for the past 5 years.
Oh, Kirk, this has been an awesome discussion. We could just talk to you for hours. I got so much stuff, but let's go into our lightning round here. So quick questions, yes or no answers, and I think we're gonna just ask you to predict the future, Kirk. So I'll go first.
Your space-time continuum machine is working well.
Let me check.
So enterprise knowledge graphs will become the top buzzword in the next couple of years. Yes or no?
Say the question again. My time machine wasn't listening.
Okay, now you're listening. Ready? So enterprise knowledge graphs will become a top buzzword in the next couple of years.
Yes.
Tim.
Perfect. All right. Number 2. So we didn't have a chance to talk too much about sort of ML and model ops and that sort of thing, but blank ops sure is kind of the thing these days, right? Blank ops, dev ops, now anything ops. The blank ops trend will continue to become more prevalent and more overused over the coming couple of years here.
If you emphasize the word overused, yes. Prevalent, therefore, yes.
All right, I'll follow with my trend. Still on knowledge graph. So knowledge graph at the edge will become a thing in the next 5 years.
Good question. I'd like to be optimistic, but 5 years might be too soon for all of that power at the edge. But so prove me wrong. Prove me wrong. I want to be proved. I want to be proved wrong.
All right.
That's a challenge, Juan.
All right.
I think it's wonderful if that happens, but prove me wrong. So
I appreciate your honest answer there because, that one I was also thinking about. I was like, 10 years, I could say maybe more confidently, right?
I'm not saying I don't want that. I want that. Just like I want that steak dinner, but it ain't going to happen.
Yeah. Once we do that, then we can really get this intelligent edge going. Okay, final lightning round question here for you, Kirk. Will all companies eventually have their digital twin?
No. It doesn't make sense. There's a lot of companies it doesn't make sense.
I love that. So whoever's listening, if you thinking you need to have a digital twin initiative, whatever, really, really think about if you need a digital twin. That's the honest, no BS, right? I love this stuff. So, all right, takeaway time. TTT. Tim, take it away with our takeaways.
Oh my goodness.
You go first.
Tim's takeaway time.
Tim's takeaway times T3. There's so much ground we covered here. I think one of the things that really came across to me was your use of the phrase small data. Like that moment kind of struck me, and I'm excited that that's becoming a little bit more of a thing, because I think when we talk about knowledge, we talk about wisdom, we talk about like, what's the point of all this big data? It was to actually unlock the next step here, which is really the small data. Like that is like, it's like it all came back. It's all full circle. We just wanted to have better small data, and we had to pass through the big data to get to it. And when you think about all the things that we're doing and pushing to the edge around intelligence and around, the AI related things, your example of the NASA, probes and things like that, it seems like it all goes around this idea of trying to be more dynamic, be smarter, and actually get back to small data at the edge. So I think that's one of my big takeaways here.
And mine quickly are, I think, Industry 4.0, it's all about hyper connectivity. Your knowledge is being transported. It's all being connected everywhere. And this honest, no BS definition of the digital twin. It's a computer model of the real thing. So if there was a problem, you can go press play and replay it and see where the glitch happened. So you can go simulate. The intelligent edge is a system to respond at the point of data collection. And basically, let's put the smarts where the data is. And hey, everybody potentially is part of it, right? We all have our phones, and our phones are our sensors. And I love the whole large amounts of small data. I think that's the way you go think about it. So we got a couple of seconds here left. Kirk, throw it back to you. What's your advice? And second, who should we invite next?
Well, my advice ties right back to our toast at the beginning, and that is about education, start of the school year. So my advice is to stay a lifelong learner. No matter where you are, what you're doing, always be in learning mode. I mean, I think, my background's physics and astronomy. Learned physics, and I did colliding galaxies and black hole accretion disks, if any of that makes any sense to people, years ago. And now I'm advising companies in medicine and cybersecurity and behavior analytics and all kinds of stuff. And it's because not that I'm any kind of special person, but I just never stop learning. I just always was learning new things. It's opened the doors for many opportunities in my life, and I encourage people to always do that. Just be on the lookout for new things to learn, because the door might open not this week or next week, but many years later. So I started learning about machine learning in 1997, 24 years ago.
Yep.
Right. And I started my own data leadership group, LLC, 4 months ago. So sometimes it takes a little while. But now I work at a startup, Dataprime. I should mention that. I work at a startup which is doing AI in all kinds of cool places. And that's what I've been doing the last 4 months. So anyway,
and who should we invite next?
I would suggest, if you haven't already had Kate Strachny on, she is just a fireball of building up the data community. She runs the Dedicated conference like 3 times, 4 times a year. I don't know. Most conferences you get people run them like 1 year and they're exhausted. I used to do that at NASA. We ran this data centers conference every 2 years. Kate runs the Dedicated conference like 4 times a year. So I think she's just an amazing knowledge community building person. I'd love to have her on and watch that episode.
Love it. Kirk, this was awesome. Thank you so much for this discussion about talking about industry revolution 4.0, intelligent edge, and there's so many more buzzwords we can do this. We should do this again. Go demystify more buzzwords. Kirk, cheers. Thank you very much.
Cheers.
It's been fantastic. Really glad to have you here.
Toast to you. Thanks for the opportunity. Really loved it.
Awesome.
Cheers.